up, dudes? We are going to what up, dudes? As always, exactly. We're going to be jumping in on this one. Let's take care of it right now. So what I want to do is I'm going to be teaching you guys how to use the 3D printer. And so the program we're going to use is called Tinkercad. Now I think that what a lot of you guys are wondering is what is the I think what a lot of you guys are wondering is what is the what's the point of doing all of that math that you made us do, right? Why do I need this whole spreadsheet of information? And why do I need to figure out the angle that each of these things are at and the model length and all of that kind of stuff? Well, the reason being is because not because I'm just like crazy and I want to it's not because I'm crazy and I want to confuse you. But the reason why I'm doing this is because I want you guys to be able to do really cool things like build something in a 3D program. The hard part about it is in order to build it in a 3D program, you need to be able to know what the length of each piece is and also the angle that each piece is. So what we need to do is we need to make a spreadsheet that will help us figure that out. So anyway, here's what I'm going to do is I'm going to make you guys go through the tutorials, which is pretty easy. When you create your own, you need to go into Tinkercad and you're going to need to create your own sign up and use your school email address for a new identity. And then what you're going to do is you're going to go through these lessons. They're very straightforward. I like them. All you got to do is like stuff like you just click on the lessons and it will show you how to do it. And then you go through the lessons. And then you can make something fun and cool. Let me show you guys how to use this to build a bridge though. So let's create a new one. And let's make the bridge that we're using. So here's the 3D program that I'm using. And what I'm going to do is I'm going to add a block in there. So I'm going to add a box right there. There we go, a box. And I want to shrink this box down to be 2 millimeters by 2 millimeters.
Are the 8th graders doing this project too?
The 8th graders are doing this project.
Did they already start it?
No, we're going to be way ahead of them. In fact, we're probably going to be the ones designing the bridge because our class is just way cooler than theirs. So check this out. This first member right here, I calculated it out to be exactly 22.63 centimeters. But what I want you to do is I want you to make what we did was we took our lengths that we had, right? Here's our calculated lengths. And what we need to do is we need to, I want to change it from centimeters to millimeters because everything that we are doing in Tinkercad is in millimeters. So in order to change something from centimeters to millimeters, you just multiply by 10. But if I multiply everything by 10, it's going to be too big for the 3D printer that I have, so I need to divide it by 2. So what I did was I made a little formula to say, hey, take all of these numbers, multiply it by 10, and divide by 2. So it's telling me, hey, you want to use a member that is 35.35 millimeters. So I'm going to take my bar and I'm lengthening it up to be 35. 35.3. I'm just going to get it as close as I can. So that's one of my members of my bridge. Let's try another one. So I just copy and paste it. And the other member that I want is going to be at, let's see, I want it to be how long? 77.78. Okay. So 77.78. Let me just go in, lengthen that out to be 77. I'm going to get it as close as I can. Oh, ran out of room. I'm going to do it right there. 77.78, which is close to 77.80. We're cool with that? Now, I'm just going to copy and paste that, put that on the side there. Now, these two guys right here are actually this member right here. It's this one right here and this one right here. So those are slanted up at exactly how many degrees? At 45 degrees. We cool? So what I need to do is I need to twist this thing to be 45 degrees. So I'm just going to use this thing. 45 degrees. 45 degrees. And I'm going to put this guy right next to this one right here. There we go. All right. So I'm done with that. Let me just take a look to see if that's pretty close. Close. Let's do one of these. There we go. All right. Next thing I need is the horizontal beam that goes all the way across. I already created something like that. Let's see. That big one over there on the bottom, that's 160 millimeters across.
Oh, has to go.
All right. You guys can go. I'll upload this recording.
No, it's like, yay.
So let's see. I want to bring this guy out to be 160 millimeters.
Does it go that far?
Yeah. There's 120. There's 145. Here's 160. Exactly. There we go. And then also, I want this thing to connect right over there. There it is. See?
Mm-hmm.
All right. The next one on top, that horizontal one, that goes out to 50. So I want this thing. Control C, Control V. I created a new one, but I only want this thing to go down to 50. All right. They never have recordings. What are you talking about? Yes, I'm reading this.
They should know how to get to it.
Oh, okay. I haven't been uploading the recordings in the class. I've been uploading them in the quizzes. Because the quizzes, the archive videos that we've been taking relate directly back to the quizzes. So when you guys do the quizzes, the first thing you see is the archive video that pertains to that thing. So if you're wondering, like, where's all the archive videos for the last classes? Well, I'm going to upload this into quiz number 4, or into the bridge building quiz number 4. And I'm going to upload the next one in. Can I put them in the conference as well? Yeah, I can try that.
That'd be helpful. It's easy to get to.
All right. I'm not going to put this one in the conference, though, because we missed that opportunity to record it. But I'll put future ones in the conference. So let's see. Member 3.1, that is 77.78. And it's exactly negative 45 degrees. So I'm going to go here, click on this, Control C, Control V. Because it's exactly the same length as the other one, but it's at negative 45 degrees. So I'm going to do one of these. And then click this thing right here and put it kind of like that. Are we cool with this? Like, you guys understand what I'm doing? And there we go. There's my 3D bridge. I built it for you. I can move. I'm going to move it to the center of the paper. But check this out, folks. I can just take that, send it to the 3D printer, and it will print it up for me. I'm done. Well, actually, this is the one I have drawn on paper, but the actual one that I have analyzed, I need 2 more members. That is going to be 118.53 centimeters. All right, so let me just take this guy, Control C, Control V. I want to shrink him down to 118.53 centimeters.
Oh yeah,
So
he already left, but Jonathan added if you could change your thing other than what updates. He added that earlier.
why? He doesn't like What Up Dudes?
I don't know. He added that
What's wrong with What Up Dudes?
though. He's like change your like in the beginning, something like that.
Change my introduction?
Yeah.
What's the problem with What Up Dudes?
I don't know. And then he added please.
Alright. You know what? I'll tell you what, remind me, but the next time we meet up, I'm going to be like, hello, Jonathan! Oh, hey, Jonathan's still here.
Oh.
He heard your conversation about him. Yeah, we were talking about you. Alright. That is exactly 118.53 centimeters at 27.64 degrees of an angle. So let's see. Let's copy and paste this thing. I just want an extra copy of it, just in case I screwed this one up. I want to move this guy to 27.64.
You could private message from Isaiah.
So, as close as I can, maybe I'll just go straight 28 because it doesn't do.
Is it really going to be that big?
Yeah, it's going to be this big. And hopefully, this piece will fit right here perfectly. Oh my goodness, look how perfect it is.
Oh my god! Maybe this side, just a little smidge. Yeah, fine.
Isn't that cool? Like how math basically helped us do this whole thing. He was like, no, I don't care.
That one, I can see it.
Right.
Do you have to make this
I just got to turn it to be exactly 28 degrees. There we go. And then this guy should fit right here.
I feel like it's gonna fit. What?
Isn't that crazy?
Yes. Oh
Like
my
now it's not
God.
all guess and check. Now I actually have a precise way of measuring. So anyway, I have this bridge. We now have this bridge. And I know that if I apply 15 kilograms of force here, this thing is actually going to be pulled apart with about a force of 15 kilograms. So to be honest with you, this bridge that I have built right here is probably not even a very good design. Because this bottom member right here had a negative 0.07. You see what I mean?
But aren't we gonna have like it like popping out so that it'd be like that, and then you make like lines right here, and then you do the same exact bottom, or how? It's just gonna be like that.
Well, you can't really tell it's a bridge, but if I take this thing and I maybe looks very 2D. Well, I'll be honest with you, I'm going to print it up in 2D like this. So what I want you to do is copy and paste it. I'm going to print 2 of them like this.
And then you're gonna put them on top of each other or something.
Well, and then what I'm going to do is I'm going to glue them. I'm going to glue them together. So here's one of my bridges, and then here's my other bridge. I'm going to group that, and then I'm going to print them up in 3D, and I'm going to glue it together.
Yeah, no one can tell it's a bridge.
All right, fine. If you want it to look like a regular bridge, I'll make it look like a regular
You have
bridge.
to do the minute now. Oh wow.
Okay, here, I'll do the regular bridge. Let's do it. So let's go. Let's go up maybe 20. Let's go with that.
Whoa. That's 20.
That's 20. Perfect.
Oh my.
Now what I'm going to do is I'm going to
But don't you?
align them to to go right on top of each other. There. And
But
there.
don't you have to put a bottom?
I will. I will.
Right there.
Now what I'm going to do is I'm going to add another box. Oh, it'll fit. And add another box. I'm going to change my snap 2 points to be. I want to go to a 2 by 2. And I want it to be 20 centimeters high. Perfect. So I'm going to add one right here.
And just drag it all the way down.
Actually, you know what? I want it to be 22. There. So I want one right here. I'll copy and paste a couple of these.
Can't you just stretch it that long?
Control C. No, I don't want to use all that wood.
Oh, I forgot.
So I'm just copying and pasting a bunch of these things.
Isaiah's trying to get your attention.
Yeah, I'm sorry. What's up? Sorry, I'm concentrating. What did you need?
He wants you to check the private chat.
All right, I'll tell you what, Isaiah. I'll check the private chat, but it's being the screen is being recorded. I can't really check the private chat without showing everyone the chat,
Sure.
because I'm also screen sharing this thing, so you can actually see everything. I'm just letting you know.
Sure.
Yeah, it's kind of no point in it being private. All right.
How about this? When you're done,
When I'm done, I'll check it. How's that? All right, let's try grouping that. And then we'll turn it like this. 90 degrees.
no.
And we'll raise it up. This, my friends, is a bridge. It won't be as structurally stable if I print it up like this, like literally like that. I should probably print it up as 2D pieces and then actually print up these bars and then glue them together. That'd be a better way of doing it. I'm just letting you know from experience in using a 3D printer. But for those of you who are freaking out and just being like, that doesn't look like a bridge. Well, it looks like a bridge now. And Maya, you're saying it's going to fall?
Yeah, when you print it, it's just going to.
Yeah. Obviously, you don't want to print it like this. I would print it like.
When laying down.
I would print it lying down like this. I would print it lying down like that.
Excellent.
And then what I would do is, I would lie it on the ground, obviously. And then what I would do is I would print it up separate as 2 pieces and then glue those 2 pieces together. You got it? But we can use a 3D printer to print up those 2 pieces. So anyone have any questions? And the reason why I was able to build this thing so quickly.
It's because you have nuts.
Oh, here, look. The reason why I was able to build this thing so quickly. Oh, Isabella, are you asking why does this bridge look like this? Is that what you're saying? Why does it look like weird like that? Oh, because this bridge, the way the competition is going to go is it's got to span this gap of space in between, and one side has to be up on top of the testing support. If you read the competition directions, you would see that it's right here.
Okay.
The competition directions are right here. Bridge design. In fact, I even have you do a homework on it. But if you look at the bridge design rules, Oh, these are actually 28 messages from last year. So I actually am updated with my messages.
Seriously?
Yeah. It's not. It's not. Those aren't messages that I like. Why don't I delete
So
them?
it just saves.
I don't know. I don't know why I don't delete them. I'll go through and delete them. All right. Anyway, I'm sorry. I was waiting for this copy of the bridge to come up. All right. Look. See. Here's how our bridge is going to be kind of hanging out on top of this test support that is 5 centimeters tall. You guys got it? So here's all the rules, and you got to read the rules, and then you'll find out, oh, okay, this is why he has those little exit boxes over here, and why his bridge is slanted like that. So, anyway, that's our 3D bridge. It doesn't actually take that long to build. I actually built it for you right in front of you. And the reason why I didn't take that long to build is because we spent all this time using our spreadsheet that we did. We calculated it all out beforehand. So by the way, L, the column L, just in case you guys were wondering, is going to be the previous column multiplied by 10 divided by 2. That's how I set up that formula. And then this one's a weird one, but I give you this instruction inside of Lab 2 on how to find the angles of all of your stuff. So that's our bridge design. I thought it was a good lab. And I think that if you guys can get me a really good 3D bridge design by Monday, then I'll have time to print it up for you and give it to you by Wednesday. And off Islanders, Isabella, you can do this too, because you can just send me your file and I will give it to you. Oh, by the way, I forgot to do something. I forgot to tell you how to save this. So you'll want to go to Properties and you'll want to rename it. And this program gives weird names. Anyway, I'm going to call it Dalday underscore Mr. underscore sample bridge 1 HSSO 2015. And wait. Do you have to take it? Do you have to take it and test it? I think Isabella, you asked, does it have to be good? My answer is, it has to be well researched. So you have to do the SkySieve and the other stuff in order for me to want to print it up. And will I test it if you send me the file? Yes, I'll print it up and I'll test it.
And what if it breaks?
And if it breaks, then we'll go back and try it again. Anyway, here's another piece of information. You got to make your visibility public, so that way you can see it. And then when I ask you to upload the file, I think all you do is just copy and paste this hyperlink into your thing, and then that will give me access to being able to see your bridge design.
Now you have 2 private messages.
Cool. Do you have to print it? No, I'm not going to print everybody's. I'm only going to choose a few to print.
The good ones that will be stable.
The good ones that will be stable, and the ones that have had a lot of the research done on them. But if you don't want to, it's fine. If you don't want to, but you still give me the file, I will not print it for you. You just let me know. Like, hey, here's my bridge. I designed it. Here's all of the math. Here's all of the science behind it. Here's all of my research, but I don't want you to print it up. Okay, that's fine. As long as you get to this point. And at this point, everyone should be, at this point, I want everyone in the class to be able to get here. After this, that's going to be only to the people who actually want to do it. Can you leave now? Yes, you are allowed to leave. Hey, I finished 10 minutes before 12 o'clock. I tried finishing before that, but you guys asked lots of questions, which is not a bad thing at all. I mean, I just wanted to try to get you guys out of here as quick as possible. In fact, I'm not dogging you guys for asking questions. That's actually a really good thing. But I tried going as quick as I could. All right. I'm going to close class and then I'm going to read these private messages.